In this section, we're going to look at three special types of straight lines, namely lines passing through the origin, lines that are horizontal, and vertical lines. Let us start with lines passing through the origin, Ursprung, or Ursprung. So this is the point 0, 0. So the y-intercept, since they pass through here, is 0. So our line equation in gradient intercept form is y equals mx plus q. The q is 0, so it simplifies to y equals mx. Let us look at example 1. We have a line that passes through the origin and through the point a minus 3, 4. And let us find now the equation of this line. Let us do it in two different ways. So A is, let us find just the gradient, the way that we have done so far always, which means we have to take ya, or delta y, sorry, divided by delta x. So ya minus the y of the origin divided by yb, xa, sorry, what am I writing? Xa minus the x of the origin. Well, ya is 4, and the origin has always coordinate 0, so I get minus 3 minus 0 in the denominator, and we get in the end minus 4 divided by 3 for the m, and so we get for the line y equals minus 4/3 times x by inserting this m here into this equation. The second way to solve it is just to say, well, we'll use that the line has the equation y equals mx, and we say the point A lies on the line. Well, it lies on the line, so its coordinates fulfill the equation. So we have 4 equals m times minus 3. We divide by minus 3 to find that m is minus 4/3, and we get again, like before, y equals minus 4/3 x. The next special type of line is the horizontal line, for example here, like this, or like this. So when we look at this, what is the gradient of such a line? Die Steigung, well, it is just 0. So we have m is 0. Using our general form, we get y equals mx, so 0x plus q. So this simplifies to y equals q. So y equals to the y-intercept. That's the equation of a horizontal line. Let us look at example 2. The line L passes through points A minus 3, 2 and B 1, 2. Let's sketch that. So we have the point B here and the point A here. And when we draw the line, we see immediately it's a horizontal line. Okay, now let us assume that we didn't realize it was a horizontal line and we would just proceed just in the normal way. Using the normal recipe means we would start with finding the gradient. So m is delta y divided by delta x, which means we'll take yb minus ya, so 2 minus 2, divided by xb, 1 minus xa, minus 3, and we get 0 divided by 4, so m is 0. So we would realize now, oh, the gradient is 0, it's a horizontal line. The other way, we realize immediately it's a horizontal line, so we just say, well, the approach is L is y equals q. If we didn't do it, we could also just say y equals mx plus q. Inserting the 0, we'll get to y equals q. And then we can just say, well, the A lies on the line. So A, y coordinate is 2, and that equals to q. So we found how much q is, and now we know the equation of the line is then just y equals 2. Now let us look at the last special type of a straight line, namely the vertical line. And this is now really a very special type, while the first two ones, the horizontal line and the line passing through the origin, are just a little bit special types of the general line. This is now very different, and this starts by that we have to write its equation in the form x equals some number, and I'll use now c for this number, some constant. Well, there is no gradient intercept form for a vertical line because the y-intercept does not exist. Let us look at some vertical lines. For example, here or here would be a vertical line. All these are vertical lines. Well, what is with the y-intercept? Well, these vertical lines are parallel to the y-axis, so they never intersect with the y-axis, which means there is no y-intercept. It does not exist. And, well, what is their gradient? How steep are they? Well, they are infinitely steep, so their gradient is actually infinity. I write this in quotation marks because this means that the gradient does not exist either. Let us look at example 3, a line given by the point A 2 minus 1 and B 2 1.7. Let's draw quickly these 2 points. So 2 minus 1 and 2 1.7. We have B and A. And so we see that the line L passing through the points A and B is a vertical line. Again, let us assume we didn't realize that, so we'll just start the normal way. We say the line L, in general, we want the gradient intercept form, so y equals mx plus q. Let's find m. Well, m is delta y divided by delta x. So we have to take yb minus ya to, 1.7 minus 1 divided by delta x, xb 2 minus xa, again 2, and we find 2.7 divided by 0, and this is not allowed. We are not allowed to divide by 0, and that's the moment when we realize, oh, why did this happen at all? This happens because the points lie on a vertical line, so the line we're looking for is a vertical line. So now, knowing that it's a vertical line, we use now this fact that we can describe a vertical line as x equals c. So the point A, for example, lies on the line. We know that its coordinate must fulfill the equation. So x of A is 2, so we get 2 equals c. Maybe we can write here, we use the line is x equals c. And so we found c is 2, so our line has the equation x equals 2. This may look a little bit strange, just let's think about it. What do we know for any point lying on this line? What can you tell me about the x-coordinate of this point? Well, the x-coordinate of this point on the line is 2. And the x-coordinate of this point on the line? Well, it's also 2. And the x-coordinate of this point here on the line? It's also 2. So what do all points on this line have in common? What they have in common is their x-coordinate is 2. And any point with x-coordinate 2 lies on the line. So the equation x equals 2, well, this is exactly fulfilled by all points that lie on this vertical line. So that's why x equals 2 is this vertical line. And in general, for x equals c, if I take, for example, this line here, we see immediately all points on this line have the x-coordinate -1. So the equation of this line will be x equals -1.